Okay, let us proceed now for the elimination of arbitrary constant. Okay, there are several ways of arriving at a differential equation. One way is by the method called the elimination of arbitrary constant. As a rule for finding the differential equation, we simply differentiate the given function or relation as many times depending on the number of constant presenting the function. Okay, examples. Okay, example number 1. Find the differential equations. Find the differential equation whose solution is given by y squared is equal to 4ax. From the given equation or function, the arbitrary constant here is the letter a. Okay. First, according to the rule, we have to differentiate. We have 2y prime is equal to 4a. Okay. Then get the value of a. We have a is equal to 2y prime over 4. Then we have to simplify. We have 1/2 y prime. We have now the value of the arbitrary constant. Okay, we have to substitute the value of a to the given function. Therefore, we have y squared is equal to 4 times the value of a, which is 1/2 y prime multiplied by x. Okay, since y prime is also equal to dy over dx, okay, but we have to simplify first. 4 divided by 2, that is equal to 2y, and your y prime is dy over dx multiplied by x. Okay, y squared, okay, y cancel. Therefore, we have y is equal to 2x dy over dx. Cross multiply, we have y dx is equal to 2x dy. Then transpose 2x dy to the left side. We have y dx minus 2x dy is equal to 0. Okay. If you notice from the final answer, there's no arbitrary constant. Okay. Number 2 example. Okay, example number 2. Again, find the DE. Differential equation. Whose solution is given by y is equal to c1 e to the negative x plus c2 e to the 2x. Okay, again, for the rule, first we have to differentiate. Okay, since we have two arbitrary constant, which is C1 and C2, we have to get for the second derivative. Kasi, di ba, according to the rule, differentiate the given function or relation as many times depending on the number of constant presenting the function. In this example, we have two arbitrary constant, the C1 and C2. Okay, first we have to get the first derivative. Therefore, we have y prime negative C1 e to the negative x plus 2C2 e to the 2x. Then, get for the second derivative, we have y double prime equal to negative times negative, that is positive, C1 e to the negative x plus 4 C2 e to the 2x. Now, let this, the given function is the equation number 1, and this one is your equation 2, and this one is the equation 3. Now, we can, uh, we, uh, we can combine or we can combine equation 1 and equation 2. From equation 1 and equation 2, we have y is equal to c1 e to the negative x plus c2 e to the 2x. Then yung second equation natin, we have y prime is equal to negative c1 e to the negative x plus 2c2 e to the 2x. Then now, we can add the two equations. Okay, y plus y prime equal to positive, positive and negative. Therefore, that is 0 plus 3c2 e to the 2x. Let this one as your fourth equation. Okay, then we can combine now the first equation and the second equation. Second equation and the third equation from equation 2 and equation 3. Okay, we have y prime equal to negative c1 e to the negative x plus 2c2 e to the 2x, and y double prime is equal to c1 e to the negative x plus 4c2 e to the 2x. Then, add the two equations. We have y prime plus y double prime equal to cancel. Okay, plus 6c2 e to the 2x. And from this, let this one as your equation number 5. Now, from equation 4 and equation 5, we have y plus y prime equal to 3c2 e to the 2x, y prime plus y double prime equal to 6c2 e to the 2x. Okay. We cannot eliminate here your C2 since you have 3 and 6. Therefore, we have to multiply this equation by negative 2. We have negative 2y minus 2y prime equal to negative is equal to negative 6c2 e to the 2x. Then we have y prime plus y double prime equal to 6c2 e to the 2x. Okay. We can add now the two equations. We have negative 2y minus y prime plus y double prime equal to 0. Okay. Therefore, for the final answer, we have y double prime minus y prime minus 2y is equal to 0.